Welcome, everyone, to Teach Me PCB. I'm your host, Mark, and I'm about to do something I don't want to do. I am going to create a custom land pattern for the Raspberry Pi Pico datasheet. Looking at this thing makes my eyes rain. It just Raspberry Pi, if you're watching, be better. Anyhow, we've got to make a land pattern, get this captured in our library, because, well, we're going to need it for our board design. Hi, Chester. Hi, baby. Chester the cat says hi. Now, let me switch to an overhead view here and just get this on screen real quick. The way that it's presented in the datasheet looks a little something like this. It gives some absolute dimensions, you know, the outer side of the pads, the inner side of the pads. Well, that lets you calculate the pad dimensions. It does give you spacing, you know, inner pad spacing, you know, so we can take this 49.86, subtract the 46.66, and that gives us the width of two pads. Here, let me switch to a slightly different view. I think it's this one. It's this one. That way you can see my face as I do this. Anyhow, 49.86 minus 46.66. That gives you the width of two pads. 46.66 minus 44.78. That gives you the width of two spacings. I don't know, Raspberry Pi organization, why you did this to me, but let's do it. And even though these are small enough to do in our head, I'm going to go ahead and plug them into the calculator anyway, because I don't want any sort of a stupid mistake sneaking in here. So I've got 3.2 as the height of each of those. You know, divide by 2, that's 1.6, of course. So these pads, these D-shaped pads, are 1.6 millimeter in width. Okay. 46.66. 44.78. Subtract them, divide by 2. Let's double check that I did that right. 46.66, 44.78, subtract them. So I've got an inner pad spacing of 0.94 mils. If I, of course, did that right, and if I looked at the right numbers. So going along all the way up and down this side, when I start with my first pad, I need a spacing of 1.6 plus 0.94 to get to the spacing of the next one. So 2.54 millimeters. These things are all just very simply 0.1 inches apart. So if you set your scale instead of millimeters to inches, which this is designed in, these things are all 0.1 inches apart. As the one guy on YouTube says, or how do I get my hands on screen? You know, it could be made much simpler there. Now, from another part of the data sheet, and if I get a chance in a minute, I'll bring the data sheets on screen. No, I won't. I don't have that computer hooked up right now. But as we go down one side and up the other, it's just 1, 2, 3, 4, 5, 6, 7, 8, you know, blah, 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 through 20. Then we start down in the bottom right corner and work our way up as 21 through 40. Now, these, most of the signal pins are all radiused at 0.2, no, I'm sorry, 0.8, and the interior sides are radiused at 0.2. I don't know a good way to tell you how to do this to keep track of all that, but it might be easier for you to stick with one measurement system. So we could stick with 2.54 and then the next one's, 5.08. We just keep adding up that way. Or we could flip everything to mils. Some software allows you to work pretty readily in between them. And we're going to make use of that. And if you excuse me for just a second, it occurs to me that I have no choice but to hook up the computer. I had it hooked up to a different computer that had the thermal software on it. But here we very much need DipTrace to do its thing. So I'm going to come up with my computer here. My friend Chester is making cat noises for us. Thank you, Chester, for singing the songs of your people. All right, so this is DipTrace's pattern editor, and I am going to create a new library. You guys can do whatever it is that you want. Hi, buddy. What's going on? What's going on over there? Going to call it Raspberry Pi Pico, and the hint is it is for the Pico carrier board. Okay. So I'm just going to call this one the Pico surface mount. The reference designator, I'm going to give it U, which is usually for microcontrollers and whatnot, instead of giving it a modular. Manufacturers, the Raspberry Pi. Data sheet, I can certainly pull up. You know something? Let me see if we can do a little something so you guys can still see me here. There should be a way to no. I'm working on it. I'm just going to push buttons till something useful happens. Logo sting, bars black. Nothing, huh? And if I change this one, it changes everything. Well, I tell you, maybe picture-in-picture doesn't want to happen today. I'm not sure. Well then. No, that's not doing me any favors either. Give me 1 minute, and if that doesn't work, I will certainly give up on my little plan of giving you... Wait, now it's working. It's going to be one of those days, I think. Okay, I'm going to edit this video, that's for sure. Anyhow, hi. Okay, so we've got a basic idea that the overall interpad spacing here is 2.54 millimeters. So if I start off, and by the way, I'm going to move my origin around a few times to make life easy for me, but if I start off and I place all my pads along the left side 2.54 millimeters apart, I will be good to go. All right, where is place a line of pads? So here I've got a bunch of pads. In fact, the default here ended up being through-hole pads. Well, we don't actually want that. We want surface mount pads that are D-shaped. I'm going to flip over to my millimeter measurements. We learned that they're 1.6. Or actually, did we figure out their height? We did not. We have to do that real quick. So I've got 22.58, 16.18. Subtract them, divide by 2. So I've got 3.2 as my width of these things. And then a corner radius of 0.8. So the rounding radius 0.8, I don't know what that ends up being percentage-wise, or if it's even going to give me a choice. It did not. It did not like that. So let's change these and see if that looks much better. Now, what is my interpad spacing? I'm going to have to set that up. Okay, so I got lucky. 2.54, so they're actually spaced the correct distance apart. How and why did that happen? I got lucky. Wonder if I can leave that measurement in place so you can see it. Okay, so each one of these pads is 2.54, which also is 0.1, right? 100 mils apart. And I've got 20 of them going down to the bottom. I know I've got a weird origin. I do plan to move that in a minute, but for now it's fine. So here's pad 20. Now I'm going to do that exact same thing. I'm going to place a string of pads going up the other side, and then I'm going to get my spacing on them and get them to where they need to be, because right now they're offset. Other thing I'd like to do is start keeping track of the pad numbers. There we go. DipTrace is not liking the fact that we're viewing it on a little 1080p screen, but my main computer monitors 4K. That's why the graphics are a little wonky. It's usually not this bad. All right. So if we go back then to our overhead view for a minute, we can figure out the pad-to-pad spacing. We know these things are 3.2 millimeters. So if I take 16.18 plus 3.2, I will have the distance to the middle of each pad, or the interpad distance. So 16.18, 3.2, whoops, don't add, I subtracted them. Bad muscle memory. So I need a distance between those of 19.38. And I doubt that I have it, but we're going to figure it out. Nope, we certainly don't. So I'm going to just nudge these to the right and see if I get lucky. Oh, I don't. So we've got to go up here and specify the distance. So I've got 19.38. And then I'm going to align all of those to the right. Align objects vertically to the right. There we go. So now I've got all of those pads at 19.38. This gives us the basic functionality of the Raspberry Pi Pico. Not everything, but it gets us a functional Pico. Now, if you want to add some other things to it, for example, you want to tap the USB. Let me see if I can give you a closer view here. USB, the differential pair are these two pins, and this is ground. These three have other functions that we don't really need, so there's not a whole lot of purpose in tapping them. You can if you want, but you don't really need to. So these are referenced from a datum, from a specific point. Where is that point? Well, that point is this point right here. So I've got to move my origin down there and then figure out where the heck that is. It looks like it's 0.79 from the left edge of this pad, and it is 0.57 from the bottom of that pad. This is my unhappy face. This is not cool, Raspberry Pi. Not cool. So I'm going to create a something. I wonder if it'll let me create a shape. Place fiducial. Okay. I mean, it's as good as anything. I just need a shape that I can move in reference to that pad. So I'm going to bring my origin down to this corner. Oh, it didn't like that. Let's increase our resolution and let's try that again. And I'm getting an error from something here. Okay, well, I can't do anything about a low bit rate right now. I'm recording and I can upload it later, YouTube. You're going to have to be happy with that. Let's get back to work over here. Okay, so that's pretty close. I might be able to get a little better. Let's bring it away and bring it back. Let's turn off our grid. That's probably better than we need. Now, I'm going to take my fiducial that I don't really need, but the fiducial is now referenced to the bottom left corner. And I know that I need the X position to be 0.57. And the Y position to be darn it, I'm sorry, the Y position is 0.57 and the X position is 0.79. Minus 0.57. Okay. Now, I need... Do I have the ability to... I'm snapping to grid. I kind of want to snap to the center of an object. There we go. That's what I want. So now that is my 0, 0 point. I no longer really need that fiducial. But just since we have it there, I'll go ahead and show my measurements. Is it going to let me snap to anything in here? It doesn't look like it. So I just have to kind of try to get close. Yeah, sorry guys. Yeah, it's as close as I can get. Sorry. Okay, and then I need a horizontal. Not going to let me snap to it again. And this one was supposed to be 0.79, which, I mean, if we round, that's going to be close enough. Okay, so that is done, or as close as I can easily get for you. Now, when I go up and I place these pads, and it gives me A and B pad geometry of 1.1 times 1.8. So I'm going to make a couple pads up here. 1, 2, 3. And I am going to give them custom pad geometry. So I just want, I guess, obround. 1.8 tall. And 1.1 wide. Is that right? Okay. Now position for this one. I am going to be at 9.5, 49.8. Whoop. Yeah, no. And then 49.8, I think I said. Same thing over here. My distance is going to be 11.5. 49.8 again. And oh, I've already forgotten 1.8 and 1.1. And we are going for obround. Of course. I screwed up there. I need to make sure this is not selected. There we go. Otherwise, I'm changing everything, which isn't good. .8, number and position. The x-coordinate is 11.5. And the y-coordinate is 49.8. The pad D needs to be custom. There we go. The x-coordinate is 10.5. And then the y-coordinate is 46.5. Okay, pad dimensions. For pad C, the datasheet gives 1.45 tall and 1.05 wide. Except it's not obround. It is, or it is obround. It's not D-shaped. So, our datasheet gives these. Now, If you want to, you can also add the SPI pins down here, but I'm going to show you an easier way to do all this in a minute. But here are the recommended pad patterns, unless I screwed something up. A, B, C, D, what are those? Pad centers shown. Great. Okay. Well, anyhow, I'm going to show you another way to do it, but we're going to finish this up first. So what we have so far is the basic idea of this. Now, we're not done. You've got to set some other things in here, too. You've got to add some courtyards. A location for where this stuff's going to be, so you don't put other pads too close. You can set the line width and all of that. I'm not going to show you how to do all that because it is a program that absolutely nobody's using. This is just kind of the basic idea of how you would do it. Up here near the top, there is going to be a USB port, so you need to give yourself plenty of distance. Let's see here. Do we have... Arg. I'm going to see if I can turn on the drawing again. I'm not seeing that toolbar. We kind of need that toolbar. Come on, dip trace. Help me out. So it says we can do it with the control button. Maybe it is hiding over here. No. It's never the easy way. I will say that. There it is. That's what I want. Now, this is... Come on. Get down out of there. No, it's not going to let me. Okay, so I'm going to expand my grid and get rid of that and draw it again. Except I want to make sure that instead of it being the silk screen, this is my courtyard. This will keep me from placing other objects too close to it. Right? Warning, object is not visible. Yes, I want to enable that. Come on, don't be that way. I'm clicking in the blind here because I have that there. Top silk, top paste, board cutout, mounting holes. Show all layers. I want to see courtyards. There we go. Yeah, just show me everything. Let's get it out of the way. All right, so we've got this thing called a courtyard. We probably want to add an additional keep out somewhere up in here for the USB, except it probably needs to be much bigger. And the other thing that you might consider doing is keeping this up towards a board edge. Because this is going to sit very close to... Oh, come on. There we go. That took. This is going to, the USB connector is going to sit very low to the board. It's going to be hard to get a connector in there. So if you put your Pico off the edge, or hang it, right at the edge of assembly area, you'll be good to go. You'll be able to do it. So that is a basic design. Another thing that you have to do is include shapes, and you can either do a triangle or a circle, but you should always get in the habit of indicating pin 1. This is something we see that people forget to do all the dang time. You can do that on your silk layer. You can do that on your assembly layer. It doesn't really matter to me, and it doesn't really matter to the assembly house, but something for a pin 1 designation so the pick and place machine knows how to rotate things. So if you were going to put your thing through reflow, we have a serviceable pattern. Not the best one I've ever done. I don't even think I'm going to bother saving it. But there you go. Now, before you commit to it, you do want to print it out. You do want to sit there and put down all of the god-awful stupid dimensions that they did and confirm that the numbers are the same or pretty close to it. Because if you screw this up, your part's not going to fit, and there's not going to be a whole lot you can do about it. You're just going to have to respin the board. So you do want to spend time to do this as well as you can, or as best as you can. Now, that is just one pattern of many. You need to go find your others. If you import them, oh, come on, this is, I might have to reboot the computer in a lower resolution to make this work. Anyhow, if you can import them, that's great, but you still need to confirm them against the data sheets, because anything that's in your in these free libraries online, man, there's always going to be something wrong, and it will screw your board over. Somebody's going to screw up the pin numbering. Somebody's going to screw up the spacing. They're going to do something wrong. So always, always, always confirm against the data sheet. Confirm units. Confirm anything that you possibly can. Okay, that was not exciting, but here's what is. I redid the pattern just because I felt this was horribly confusing for people. It confused me. I can get through it, but if it's confusing, it's going to lead to mistakes, and mistakes lead to respins. And even though I went through and I redid all of this, when I did my board, I had those 3 spots off. They were all shifted over. I couldn't get USB on my Pico working on my proto board. No USB. It made me so mad. Anyhow, as a favor to you, dear reader, I've got all the numbers for you here. This will be available inside the course. So you can go through and double check your pad locations to figure out where everything is. That's it for now. That's certainly not all I have to say on the subject, but that's it for now. So with that, hopefully that was okay. And I will try to get that edited down and into the course for you. So thanks so much. Bye.